Hi, my name is Julián Cortés, and today I would like to share with you a research in progress with Catalina Ramirez on the structural view of science, technology, and innovation policy in Colombia. Once a year, world leaders go to the United Nations to the General Assembly. During this assembly, they sent a message, a missive to the international community, which is a form of discourse filled with their international government priorities, both international and national government priorities. On the left side, we have, and also we can see the introductory section of a discourse of Juan Manuel Santos, who focused his government efforts on peace negotiations. In contrast, on the right side is Iván Duque, who had just finished his period. In the same line, his government priorities were revolving legality, entrepreneurship, and equality. With that in mind, we suspect every government has its science, technology, and innovation policy agenda, right? However, science, technology, and innovation policy might change for the next government. So the question we ask here is how to study the changing structure of science, technology, and innovation policy. Therefore, our study aims to understand the underlying structure of science, technology, and innovation policy in the key disciplines or research areas explicitly supported for the case of Colombia between 2005 and 2018 via cohort network analysis as a pilot study. In simple terms, we found that for the case of Colombia, government A prioritized physical sciences and life sciences. On the other hand, government B prioritized health sciences and also sort of balance the participation of all areas. We also identified that the three fields with the highest weighted degree in both governments were renewable energy, sustainable and environment, general agriculture and biological sciences, and general medicine. In the upcoming sections, I will explain in detail how we got those results. Okay, let me present the materials and methods. We hand-curated the research fields explicitly mentioned and supported in public research calls managed by Colciencias, now the National Ministry of Science, Technology and Innovation. The archive enabled us to process over 300 calls from 2005 to 2018. We standardized the research fields using the ASGC system to avoid redundancies. Then we select only the calls with 3 or more fields and modeled a cohort network. We modeled 2 cohort networks for 2 different government periods. In the inferior part of the slide, you will be able to see how we proceed to process the strategic fields supported by the calls and then turn those fields into cohort networks. In the right side, you also will be able to see the calls that we process for government A and government B. Also, you will be able to see the number of calls that we process by year. Okay, so for government A, there was a visible protagonism for physical sciences, as you can see. The most crowded cluster has a balance composition of all research areas, particularly led by life sciences. Also, social sciences and humanities related fields are consistently embedded in all 5 clusters. Finally, the fields with the higher weighted degree by area were general medicine, general agricultural and biological sciences, renewable energy, sustainable and environment, and management of technology and innovation. Now, for government B, we have these results, and there was a higher field communities definition since all fields were grounded in 4 instead of 5 clusters. Health sciences composition almost doubled, while physical sciences decreased. The composition of life sciences and social sciences was relatively stable. Finally, the nodes with the highest weighted degree by area were quite similar. For instance, renewable energy, sustainability and environment, general agricultural and biological sciences, sociology and political science, which displays management of technology and innovation, and finally, general medicine. Here we have the results of that we were talking about just a few moments in terms of the key areas of administration B. To conclude, our study gives an overview based on well-established techniques to empirically study the structure of science policy and the changes produced by a new government in office. It can be used in the public sector to really understand the path-dependent trajectory of science, technology and innovation policies, also to map the key areas, the under-supported fields and disciplinary diversity in science, technology and innovation policy. In further stage of the project, we will explore the effect of such science, technology and innovation policies, and also how these policies might be able to shape the incentives for the workforce in science at the national level. Also, we will use more robust network indicators, and of course we will need to control for other variables. So that is the main purpose of our study, and we look forward to exchange with you guys ideas of these in progress findings of our study. Here you will find the contact of the corresponding author, which is me, and we will be eager to address your questions. Thank you.